ध्वनिर्वर्णापदं वाक्यमित्यास्पदचतुष्टयम् यस्याः सूक्ष्मादिभेदे वाग्देवीं तामुपास्महे।
Electronic Media Production and Research Center of Madhya Pradesh, Bhoj Open University presents its audio series of Eminent Scholars Lecture. In this series, today we have invited eminent nuclear scientist of India, Dr. R. Chidambaram, and he is going to deliver his lecture on nuclear energy to rural development. This program is recorded, edited and directed by Shri Amar Bahadur Yadav. Let's listen to the lecture of eminent nuclear scientist Dr. R. Chidambaram on nuclear energy to rural development.
What I want to talk today is I've chosen the topic somewhat deliberately, nuclear energy to rural development. India is a very large country and its development needs are also equally huge. I always say India is too big a country to absent itself from any field of science and technology. But how much it invests in any field at any point of time is a matter of wisdom, because it depends also on the boundary conditions, human resources, financial resources and all that. In some sense, nuclear energy is a symbol of high technology. And in a developing country like India, it has also been a catalyst for development in many areas of high technology. Talked about nuclear being dropped from magnetic resonance imaging. Germany, they dropped, more or less they dropped K from KFA Jülich and KFK Karlsruhe. K was at least suppressed. But this is what I'm going to talk a little bit more later, that we have to use technology foresight to define our own needs. I'm going to tell you that there are just not enough fossil fuel in the world to satisfy the needs of developing countries. So those countries which have the luxury of alternate sources, which have the financial resources to access the world's resources in the Middle East, let us say, they can take positions which we cannot take. Because if we follow what they are doing, it may not be good for the country. So anyway, nuclear technology in some fashion is a symbol of high technology. And on the other end of the spectrum, we have rural development. Much of rural development in this country can be done without access to high science and technology. Applying known science and technology to agriculture, rural industries, and I'm going to give some examples of that. So I chose this to represent that nuclear energy to rural development spans the kind of range of technologies which India needs to develop, and this kind of choices of technologies which India should make has to be done on a national perspective. We should not be guided by the decisions of other countries, developed countries, whose quality of life is very high already and whose choices are determined by maintaining this quality of life. Whereas our choices must be determined by what we should be doing to achieve the kind of quality of life they have already achieved. And so I suggested to Professor Swaminathan, would be willing to take up a project on nuclear and biotechnological tools in coastal systems research. That is how to improve the livelihood of people living around coastal nuclear power stations. And in fact, I started a Homi Bhabha chair with the most unusual name, which is Nuclear Science and Rural Societies. So it's not that I have become interested in rural development only after my recent assignment or of taking over TIFAC, but this is something which has been interesting me for a long time. So what they have done a marvelous job. They took a 10-acre plot in the Indira Gandhi Center for Atomic Research. 1 acre collects rainwater and they do fish farming there. And after the fish has been harvested, that water has got nutrient value and it is used to grow pulses. The pulses they grow are radiation mutants developed in the Bhabha Atomic Research Center. Radiation mutation is a method of developing new varieties. It is not genetic engineering. It's not like transferring a gene, which work is also going on in the country. These are random mutations caused by radiation, and then you select. And this is how nature has created mutations which people have accepted over millennia. And what we do is we make sure that the favorable mutation, which is say gives you increased yield or increased pot size in the case of groundnuts, or if you do if you get pest resistance, you make sure that the genetic mutation is stable over several generations, usually 7 generations. Then we link up with an agricultural university in order to see what is done in the laboratory is also possible to do in the field, and then it is taken through the varietal seeds distribution program of the government to various states. For example, when we say TAU 24, TAU 24, pulses black gram or something like that, or TGU, whatever. T stands for Trombe, A stands for Akola University, Agricultural University. This is how the thing is propagated. And these are the radiation mutants which Professor Swaminathan and his colleagues, Professor P.C. Kesavan, is really now the executive director, and he's the Homi Bhabha professor. What they do is, the pulses they grow in a field in which they use a kind of algae which was developed again by Bach, which removes salinity from the soil, so that when the pulses are grown, this salinity is not there. But once the pulses are harvested, you plow it back so that you don't want to disturb the ecology of the coastal region. And this has been a very successful experiment. Kudankulam is a much bigger program. It's a 2000 megawatts, 2 into 1000 megawatts we are building there. There's advanced light water reactors we are building with Russian collaboration. And here what they have done is to create, because it's a low rainfall area compared to Kalpakam. So they have looked at the neem and tamarind, special kinds of tamarind, trees which grow well under low rainfall, and so that the whole belt has to be green. This is a statutory requirement, regulatory requirement for a nuclear power plant. And they also developed a genetic garden with varieties of fruits and other kinds of plants which can be grown in that region. They have also done something which is called the Village Knowledge Center at a nearby place called Idindagarai. These are fishermen's village, and they are teaching them. For instance, see, when you see your weather report on the television, that map means nothing to the fisherman. He wants to know that if I go out fishing today, will I come back safely after 24 hours? So he would like to be told what will be the height of the waves in meters or whatever in the next 24 hours. And this kind of information is now available. National Remote Sensing Agency, which gets all this information. And the Department of Ocean Development in Hyderabad has an excellent institute called Institute of Ocean Information Services. And now if you can link up this kind of information, what I call locale specific, demand driven information, can be made available to the people who really want it. They also want to know if they can market their fish in more than one place, what is the price here and there. If they are told, they'll go to the place where the market is more. And it was very interesting when we went there to see the demonstration. These are all semi-literate women, young girls who had not studied very much, but they take to this kind of a computer-based information system like, shall I say, fish to water, poor pun, but that's the way they do it. So this whole project which we had with the Swaminathan Foundation has been very, very impressive. But we have continued that. See, I'm going to come back later to the need, particularly in rural areas, for value addition to food. Food processing is something very, very important for India. This was done under TIFAC. TIFAC is a Technology Information Forecasting and Assessment Council. It is part of the Department of Science and Technology. I happen to be the chairman of the council. And we have started, of course, they have been doing food processing for a long time. But after the last 1 year, we have started doing fisheries. And this was a village in Vasai Creek. People who are familiar with Maharashtra. Vasai Creek, Kalam village. And this project has again taken off very fast. TIFAC does not usually give grants. It operates with industry, homegrown technologies, or it operates with cooperatives. And this was a women's cooperative. These are all fisher women. It's run by women. And each one of them had contributed 20,000 rupees for this cooperative. And the chairman is very interestingly, I have been told in Asian countries that if you give a loan to a woman industrialist, the money is likely to come back more than if you give it to a male. For some reason, they are more honest. It has been seen in Bangladesh, we have seen it in India. Simple things like prawn pickles and fish papad, these are the two products. But these are the kind of things which add value to food. But if they do it themselves, it doesn't have value. But what has happened is there is a very good institute in Warsaw, near Bombay, it's part of Bombay. It's called the Central Institute of Fisheries Education, which is a deemed university. And that institute have taught these fisher women how to process it to international standards. So what they are marketing is a product which is up to international standards, because that is something we have to do. Something which you consume locally within is okay. You try to improve the quality, but when you are trying to market it, whether it is a car, a reactor, or a drug, or even prawn pickles, I suppose, you must have high international standards, and that's beginning to happen. See, let me come back to nuclear. Great deal of technology foresight was shown by the people, Homi Bhabha, and the pioneers who followed him in delineating the entire program. The 3-stage nuclear program. They chose very carefully the fact that we must go ahead for pressurized heavy water reactors rather than light water reactors. The advantage is India has a very limited resources of uranium, but it has got the world's highest resources of thorium. Suppose you use the uranium, of course, like we found gas, I'm sure we are going to find more of this. We don't have anything like the Cigar Lake in Canada, where the uranium is maybe 20% or more of uranium in the rock which they mine. The rock which we have in Jadugoda, in Jharkhand, is less than 0.1%. So this is a very low grade uranium which we have struck so far. All indications are from the geology of the country. Maybe we'll get lucky. Somewhere we are going to strike. But at the moment, if you take the uranium which we have and take it once through in pressurized heavy water reactors, it is something like 1% of our coal reserves. No big deal. Most of you know, less than 1% of uranium is U-235, which is the one that burns in the reactor. The rest of it is 99+%. But if left in the reactor, it will pick up a neutron, give 2 beta particles, and becomes plutonium-239. That plutonium-239 can be used in fast breeder reactors. Reactors which use not thermal neutrons but fast neutrons, and which breed more fuel than they consume. And that is why it's important for us to close the nuclear fuel cycle. For their own reasons, the Americans don't want to close the nuclear fuel cycle, because they feel if they take out the plutonium, firstly the uranium prices in the world are cheap. Why would they bother to produce plutonium when the world prices are running so low? So they spent fuel as waste in the Yucca Mountains. That's where they have chosen as the geological repository. But that plutonium is not running away anywhere. Plutonium has a half-life of 24,000 years. So this Yucca Mountain will become a plutonium mine. And the longer you take to reprocess, the better it is for you, because all the other activities will begin to die down. Normally we wait for 3 years before reprocessing, even us, because we don't want short-lived radioactivities, because it makes it more difficult even by remote handling. to reprocess when you try to take out plutonium from the spent fuel. But for us, if we are able to successfully take out the plutonium and put it back into fast breeder reactors, the total thing, that's why the entire, some guys from Indira Gandhi Center, because they will talk of Raman effect and amorphization and all that. But the basic thing, the basic mandate of the Indira Gandhi Center for Atomic Research is fast breeder reactors. If that program is implemented, the total thing is something like 50% of our coal reserves. But we have the world's biggest reserves of thorium, as I said. If thorium is used as a blanket in these fast breeder reactors, thorium-232 put into the reactor will again pick up a neutron, emit a couple of beta particles, that's electrons. That's why the atomic number goes up and become uranium-233. And suppose we are able to successfully go into the thorium-U-233 cycle, then our entire uranium-thorium reserves is something like 3 to 5 times of our coal reserves. That is the kind of payoff which is possible by doing this 3-stage nuclear power program. Of course, we built over the years, decades, a very strong nuclear program. We could do this credible minimum nuclear deterrent. We could test the devices and we can have whatever we need for nuclear deterrence. Spin-offs in agriculture, medicine and industry. Radiation mutants I mentioned. Industry, you find that you can do radiography, gamma radiography, as well as you can do X-ray radiography. If you call forensic probably comes forensic industry. You want to do whether a guy has been smuggling gold in a belt which is tied around his stomach. All you have to do in the cloth belt, take a nitric acid swipe, put it into the reactor, and it will show that tiny gold radioactivity there. Or somebody has been killed with arsenic. You take a bit of his hair, provided he has hair, and put it into the reactor. And also take hair from the control people. And you can see that this guy has been killed with arsenic poisoning. Many people do not know that every major murder case is referred to Bach to see through neutron activation analysis. Some guy says, look, I have only handled this gun, that's why you find the fingerprint there. But I have not fired the gun. You take a swipe from the web, back of the web, put it into the reactor. You can find out the guy really just handled the gun or really fired the gun. And as I said, there's this entire forensic field, this kind of application of, and then of course the standard thing, cobalt-60 for teletherapy, or if somebody has breast cancer or tongue cancer, to brachytherapy, put needles containing radioactivity to kill the cancerous tissue. All those, and nuclear medicine, radioimmunoassay, radiopharmaceuticals. There are hundreds of nuclear medicine centers in this country which are regularly supplied radioisotopes and radiopharmaceutical products by the Board of Radiation and Isotope Technology. Development of major facilities for research. See, building a reactor or building a nuclear weapon is not one technology or one science. It's a mixture of disciplines. And in a similar way, if suppose you want to build an accelerator, it's not one technology. You must have people who are experts in high voltage, high vacuum, cryogenics, beam dynamics, materials. And that kind of technological capability at the moment is there only with the Department of Atomic Energy. That's why you find Center for Advanced Technology, which is in Madhya Pradesh, building synchrotron radiation sources. Or you have the Calcutta people building a superconducting cyclotron. Or the Institute of Plasma Research, which has now been taken over by the Department of Atomic Energy, building a steady-state superconducting tokamak. Because once you come to high technology field, which are needed for research, one finds that the kind of capabilities which exist with the Department of Atomic Energy become very valuable. This is a project which has always attracted me, but I have not yet been able to sell it to everybody, but I'll show it to you anyway. Rural India, many of the deliveries, the baby births, are still done by dais, midwives. And here, the kit that they use is ridiculously cheap, just 15 rupees per birth. But any infection that you introduce at that time can be disastrous both for the mother, for the baby, and for society, which then has to do things in order to cure in one way or another, the society pays a price. So this kind of the basic kit, which is a draw sheet, which a pair of gloves, blade, with all this stuff, just 15 rupees per kit. And our calculation is that if you can radiation sterilize this, make a disposable dye kit, midwife kit, because we want a time when India becomes a fully developed country and everybody in the rural area has hospital care, where the baby is delivered in the hospital like your children or your family children and mine. But here, cost of irradiation is just maybe a rupee and a half. Ridiculously cheap. But only thing is a matter of management, it's a matter of distribution of these kits, ensuring that these are disposable and recovered. And if you do that, the capital cost for one unit is just 6.2 crores. Nothing. 4 such kits can take care of the entire requirements of rural India. So here is a direct connection, not a remote connection. You use radiation, cobalt-60 radiation, to sterilize, just like we do hospital supplies, bandages and syringes and so on. You can do these dye kits, and one can really take care of the health damage that can come from unhygienic conditions in rural childbirths. So I ask myself the question, actually all of us, we want India to become a developed country. And each one of us has perhaps a different definition. My definition, I will consider India to have become a developed country when the quality of life in rural India becomes comparable to the quality of life in the non-urban areas of already developed countries. All other measures are kind of submerged in this one single measure of the definition of development. The United Nations over the years has been developing an index called Human Development Index, and in which we have not come out obviously at the top. And they use 3 parameters: per capita GNP, life expectancy at birth, adult literacy. I've been saying for almost a decade now that for a country like India you need only 2 parameters: per capita electricity consumption and female literacy. Female literacy I prefer to adult literacy, because if you look at statistics, you find that whenever, in every state of India, female literacy is lower than male literacy. And the difference is more the lower the average literacy. And because female literacy is a measure not only of literacy, but of equity and justice in that society. A society is not equitable, is not just. One of the weak sections which are oppressed are the women. And that's why I prefer female literacy as a measure of development. Per capita GNP, per capita electricity consumption, monotonically related. More electricity you consume, more goods you produce, more are the services you provide, and obviously your per capita GNP will go up. So per capita GNP can be replaced by per capita electricity consumption. Life expectancy at birth can be replaced by per capita electricity consumption. For a developing country like India, both these parameters can be taken care of by one: per capita electricity consumption. See, you and I are the fortunate people, operate from air-conditioned offices, travel by air. Our energy consumption is far above the national average. And there are a number of people in India, the poor people, whom I say always occur only in the denominator. When you take a statistics, they don't contribute to the numerator, only to the denominator. And India has grown, no question, from independence onwards. India's life expectancy has grown and grown and grown. We are somewhere here, 62 years. 62 years. Female life expectancy is somewhat lower than male expectancy. So the female of the species is a sturdier animal, by and large, biologically. You plot life expectancy in various states in India against per capita electricity consumption. Suddenly you will find Kerala standing way out because of the female literacy there. Female literacy is very high. Gandhiji said, if you educate a male, you educate one person. If you educate a female, you educate the whole family. But more quantitatively speaking, if you plot infant mortality against female literacy, you find a strong correlation. You plot birth rate against female literacy, you find a strong correlation. There is no question that if India is to become a developed country, I am not saying only the female should be educated. I am only saying as a measure of development, we must become 100% literate, near 100% literate. It's a basic condition for development. and it should be done without gender discrimination. And that's why the question of female literacy comes up. Any way you calculate, you have to increase our per capita electricity consumption by 8 times or something like that. And the reason is, you introduce any electricity producing system, part of it will go to industry, part will go to urban consumption, but a part will also go to small towns and villages. We'll get better drinking water, better sanitation, better primary health care, and all this has got an effect on health parameters, particularly the ultimate health parameter, which is life expectancy at birth. If you come back to the Indian nuclear program, we have something like a little less than 3,000 megawatts now, but this is a self-reliant program. We have created a platform for launching a very big program. And at the moment, 8 reactors are simultaneously under construction. And this is a world record at the moment. We have had the success with the fast breeder test reactor at Kalpakkam. The fuel there, which is a new kind of fuel, mixed uranium-plutonium carbide fuel, has been very successful. It's cost, I don't know, Aurora, it's past 100,000 megawatts days per ton. And you cut open the fuel is in excellent condition. So we have tremendous experience with every component of the technology of the fast breeder reactor. And very shortly we are going to start our prototype fast breeder reactor, which will be 500 megawatt, which will be the 9th reactor simultaneously under construction. See, this is very interesting that today our average capacity factors are running at close to 90%, and it has continuously grown. It's not just because the Department of Atomic Energy is running these plants well, there's better maintenance management, but the services and spares that you get from Indian industry, that quality has also gone up very substantial. And when you come to 85-90% average capacity factors, it becomes comparable to the world's best. So that's where it is now operating. And the gestation period for building a new nuclear power plant has come down. It used to be 7 years. Now it is probably 5.5 years. And every time I see V.K. Chaturvedi, who is the CMD of the Nuclear Power Corporation, he brings it down by a few months. Means the momentum for bringing down the gestation period for building new nuclear power plants has come down. And Indian rupee has gotten stronger over the years. Today the interest rates are down. And over the years, in fact for a long time, we are appreciating against the dollar. It's not a bad idea. Except for the poor retired people who find their pension, whatever they put it in fixed deposit has gone down. But for those guys, everybody else is happy that the interest rates are going down. And for all infrastructure projects, including nuclear power projects, where the interest during construction was a big component, that factor has started coming down. And I remember in my days I used to fight for money for the Nuclear Power Corporation. Not so much for the R&D institutions, but for the Nuclear Power Corporation. But today, everybody else wants us to build more nuclear power plants. When the Rawat Bhata 3 and 4 was dedicated to the nation by the Prime Minister, Suresh Prabhu was then the Central Minister for Power. See, this target we have put there, 20,000 megawatt by the year 2020 is now entirely achievable. No problem at all. Already 4,000 megawatts are in the pipeline under construction. And the idea was that towards the end of this period, say the decade, the second decade, this target was set in 1995 when we had a big Vision 2020 discussion in the Department of Atomic Energy. I had called all those people who are heads of their institutions, tell us how they see their institution emerging 25 years from then, which was 1995. And I had put a boundary condition that only people in the age group of 35 to 45 will speak, which means they are the ones who are going to see there. And of course, many people who pretended to be young also spoke. I also spoke. But by and large, most of it was done by the people in that age group. And this formula of 20,000 megawatts by the year 2020 came as a result of that discussion. But Suresh Prabhu, in that Rawat Bhata meeting, said that you should aim for more. Instead of 1,000 megawatt per year, you should really aim for 2,000 megawatt. See, today, in the field of nuclear energy, people outside the Department of Atomic Energy, they want us to do more. There was a time when we were saying, give us more money. Now they are saying money is not the problem. Which is true, internal resource generation is high. And in the last few months I heard, the Department of Atomic Energy went to the Atomic Energy Commission and said, with the same money that you are giving us for Kaiga 3 and 4, don't increase the budgetary support, we'll build 2 more reactors. So that's the kind of situation which is very different from what was there a decade back. See, we must see, I talked about nuclear technology, I talked about technology related to rural development. You must be clear, why do you want to develop technology? Want to create national wealth? You want to improve the quality of life of the people, particularly those living in rural areas, and you want to enhance national security. National security you essentially mean in a military sense, but in a broader sense, it also means food security, water security, health security, environmental security. You can also broad base it in the context, in which case, of course, it gets mixed up with the earlier two criteria which we have put. And also you want to create an infrastructure development for research. Not only should you do good research, but you should be able to build facilities for research. You should be able to build instruments for research, which Rajagopal used to do. But that culture has unfortunately come down a little bit, because those are days, decades back, when foreign exchange was in shortage. So we were compelled to build our own instruments. And now it has become easier, so most people tend, of course some instruments you have to, whether it's medical diagnostic instruments, analytical instruments. I always say there's a Lakshman Rekha. Before that, you produce indigenously. Beyond that, you get people from outside to bring their manufacturing base here. And today, more than half the cost of an instrument is software. And hardware doesn't change so much. Software does. The work that is being done on interpretation of the images, once you've got the image, great deal of effort is being done there. And that's software. Hardware is not changing very fast. So my advice has been, who are better than Indians in software? You ask Silicon Valley guys. So it's a good inducement for people to bring their manufacturing base here, the upper end of analytical instruments and medical diagnostic instruments. How to select technologies which you need for development, having decided what is the purpose for technology development. Technology foresight is different from technology forecasting. You can ask yourself the question purely from a scientific and technological angle. You can ask yourself the question, can a missile be intercepted by another missile by impact and neutralized? You can ask the question, will human cloning work? Purely from a scientific and technological angle. Or you can ask, will DNA computing work? That is, you have the sequence of databases, you process it, you get another sequence which is the answer. Suppose you ask these things purely from a scientific and technological angle, that is forecasting. But suppose you add to it social, economic, environmental aspects and then decide, is it necessary for your country? Then you get different answers. You ask the question from India, or you ask the question from, let us say, the United States. You may not get. Sometimes you may get the same answer. Sometimes you will get a different answer. And that is what technology foresight is all about. I told you I am chairman of this body, TIFAC, Technology, Information, Forecasting, Assessment Council. Forecasting plus assessment is foresight. So in a way F is there. So I pretend F can also stand for foresight in TIFAC. As I said, this has to be based on a national perspective. Suppose you ask, fast breeder reactors, are they necessary? India says emphatically yes. Because without closing the nuclear fuel cycle, somewhere I said, closing the nuclear fuel cycle, the newspaper man thought I am saying ending the nuclear fuel cycle. Close the loop. Take the plutonium back, put it into fast breeder reactors. Or you can close the cycle with thorium. That is important for India. Why would Americans bother at this point of time about fast breeder reactors? Or a country which gets its electricity from France, why would they bother? They can shut down their nuclear power program over a period of time. Maybe. I hope they won't. But in the case of the United States, why would they bother about fast breeder reactors when uranium is selling so cheap? And when they are worried about proliferation? They think the plutonium that's taken out may go into nuclear weapons. So their mind is clouded. Well, maybe if I'm an American, I'll do the same thing. But I'm in India. So I look at it from an Indian point of view. It is absolutely essential for us to go for fast breeder reactors, for us to go for reprocessing, and for us to close the cycle with thorium, which is the ultimate fuel for us. You take rural food processing. Why would the Americans worry about rural food processing when their products can reach every part of the country so easily? Whereas for India, rural food processing is something very important. And this has to be treated on a different scale. Potato is 2 rupees a kilo, but Uncle Chips is 200 rupees a kilo. That's the kind of cost difference which comes as a result of food processing. You don't have to do that for rural food processing. You produce, consume within a radius, like the prawn pickles, which I was telling you about, is sold by this women's cooperative on a door-to-door basis with a close proximity. Because many of these women or many of these small entrepreneurs cannot advertise. You cannot, send the Indian cricket team, Sachin Tendulkar and all that. B.Sc can do, but the poor women's cooperative cannot do that. But they can kill them on price and do it on a local. So for us, rural food processing is very important. There is an institute near Vienna called International Institute of Advanced Systems Analysis, started by the Russians and the Americans, just to get those guys together immediately when the Cold War was at its peak. Now, of course, they do analysis on a very broader spectrum. And TIFAC and EASA had a meeting some time back. And one of the scientists who were there, who was making the presentation from EASA, showed a thing called European Rural Development. So at the end of the talk, I asked him, I thought you guys are fully developed, rural or otherwise, rural or urban. What is this European Rural Development? But he said their problem is the potential leaders in rural areas tend to migrate to urban areas. Which is exactly the problem we have. People who can be potential leaders there. Similarly, people who can be potential leaders in urban areas migrate to the United States. Same drive, same motivation. So the question is how to create an environment. Of course, many of us have not migrated. Lakshman Sai Modalyar, he was the Vice Chancellor of Madras University. That's decades back was asked this question about what do you think about the brain drain. He said it's not brain drain, it's brain overflow. But we have to create an environment so that in urban areas we can keep our young potential leaders. We have to create an environment in rural areas so that the young potential leaders decide to stay back there. Next one, please. And what are the critical technologies for India today? In my opinion, strategic technologies, nuclear, space, security related, dual-use technologies denied to India, technologies related to energy security, health and water security, environmental security, advanced manufacturing processing, advanced materials. Right at the top, I put rural development related technologies for the growth of India. And of course, this is a dynamic exercise. What you decide today may not be valid after 5 years. It's very interesting to remember that when President Franklin Roosevelt asked the senior statesman to give him an advice on what will be the technologies which will become important after 25 years. Very useful to remember what the things they missed. They missed rocketry, they missed lasers, they missed transistors, they missed genetic engineering, they also missed nuclear energy. Otherwise, I wouldn't have a job. Because nuclear fission was discovered 1 year after they gave their report. So it's a dynamic exercise. Technology foresight, because there's a prediction there, things may change completely or partially over a period of time. Rural development is being given the highest priority in the 10th plan. As you all know, 2/3 of Indians live in villages. And like in any physical phenomenon, any physical by and large, tends to grow fast initially, then it saturates. Agricultural productivity as a function of inputs grows very fast initially, then it saturates. And we had Professor S.K. Sinha, who was the former director of the Indian Agricultural Research Institute. After retirement, he has gone to the poorest places in Bihar and eastern UP and have shown that at no extra cost, you can double the agricultural productivity. No big science and technology, just good agronomic practices which the poor farmers are not aware of. Give them good seed material, then you can double agricultural productivity. But on the other hand, if you go to a place where already the productivity is high, increasing productivity there would require tremendous extra inputs in terms of fertilizers, in terms of pesticides, which anyway has a very negative effect, which has already had a very negative effect in Haryana and Punjab on the soil and Rural industries. If 3% of the Americans can produce all the food that they need, why should 66% of Indians produce all the food that we need? In a situation where in principle we have access to the same science and technology. We have the same access to BT cotton or whatever genetically modified crops. So it's very important that you must go away from the primary. Lesser number of people must be involved in the primary food sector, whether it's agriculture, whether it is fisheries, and they must go to food processing, value addition by food. You must improve the quality in arts and crafts. And of course you must do medicinal herbs. Tremendous medicinal herbs possibilities are there. But you must put the right herbs inside. If you don't know what herbs you are putting, naturally the product has no value. And that's why things like CMAP in Lucknow or the JS College of Pharmacy in Uttakaman, they are not using various spectroscopic methods or gene markers in order to tell. Because these herbs very often look alike. And in order to make sure that you are getting the right input. Two modalities in my opinion, nucleation and growth like in crystallography. If you have a person like S.K. Sinha who's willing to go and work with the villagers, and it takes time for them to believe you, because they are villagers in India have a lot of common sense. And if you go in your air-conditioned car once a week, they know you are a phony. You have to live with them. Then they begin to believe you. Then they begin to accept your advice. That's what happened with S.K. Sinha. In 2 years, they doubled their productivity. And I was telling for a person who is below the poverty line, the improvement in the quality of life is a very non-linear function of his income. Suppose you are earning 100 rupees and you spend 90 rupees on keeping your body and soul together. Your quality of life is proportional to 100 minus 90, 10 rupees. But suppose you earn 200 rupees. Even if you do this job of keeping body and soul together a little better than before, say 120 rupees. 200 minus 120 is 80 rupees. So you see, in the early stages, that's what happened to us in the 5th pay commission, by the way. Quality of life went up. Extra money we had suddenly began to go up very substantially. The other one is networking. That is, see, we don't know their problems. The question is, there is no point in providing solutions for problems which don't exist. First, we have to learn the problems of rural India. And there is a body called the Akhil Bharatiya Gramodyog Mahasangh. It's a federation of under KVIC, which is linked to something like 250,000 villages. So as I mentioned a little earlier, we have gotten together, TIFAC and them, we have MOU. And they tell us the problem, and the TIFAC tries to see if we can give a solution. Then they try to spread it. And things like, I mentioned, I think, about terracotta. This, for example, we started on rural pottery. And this has worked extremely well, where we had the ceramic specialist, Sopan Guha from Jaipur Ceramics, telling these rural potters how to cut down their waste and how to go from terracotta to glazed terracotta stoneware. And if you do that, I am told, the rejection rate can be halved. You don't realize that 70% of all the things which the rural guy makes, he throws it away because it has some kind of a defect or not. And it can be brought down to 30%. And if you go to glazed terracotta and stoneware, from 4 rupees a kilo, it goes to 40 rupees a kilo. That's the kind of value addition that can take place in rural industries, provided, because for every rural industry, there is an equivalent modern industry. If you can get those guys together, and there's a surprisingly large number of people who are willing to do that, willing to help, much more than when I expected when I took this job. Very large number of people who have given up IIT positions. There are all kinds of people who are there spread over India. The question is how to bring them together and help them, because all our technology development has to be backed by research and development. As far as basic research is concerned, I think it's a cultural necessity. Any civilized country must allow its highest intellects to work on fundamental problems of their choice. Don't ask them why they are doing. But everything else which is applied research and technology development must relate to Indian industry and must relate to the critical technologies which we have selected. Mission-oriented agency work and all that. We want international S&T cooperation. We have been defining, when we started, I remember when we were there, Rajagopal and I'm talking about 1956, we made a stabilized power supply using Elmore and Sands. We thought it was a good job done. Or when we built the Apsara reactor. At that time, the aim was to do something for the first time in the country. Today, the things are different. Whatever you build a product, it has to be internationally competitive. Dr. Reddy's or Ranbaxy's cannot say, look, my drug is not good enough, but I'll sell it in India. Nobody will buy it. Because now it's under the new liberalized regime. But they're able to challenge. Now they're able to talk about new molecules that they will produce. Self-reliance, that's why I don't define, I have been for many years now, as self-sufficiency. But as immunity against technology denial. Something is available to you, which you can put it as part of your complex system. Go ahead and do it. But if anything is denied to you, including the proverbial wheel, you must have the capability to do it yourself. That's why I call self-defining self-reliance as immunity against technology denial. But then we must go for international cooperation. But today's India can easily and confidently go on an equal partner basis. And as chairman of the International Atomic Energy Agency for that period, I remember some of the developed countries saying they are developing from donor fatigue. Donor fatigue. They've been giving away to recipients for a long time. Now they are tired. And that is the time I decided I will develop this definition of self-reliance. It's certainly applicable to India. And we must go for international mega science projects like we're doing for the Large Hadron Collider in Geneva. As you know, this is an ultimate accelerator in high energy physics. Multi-tera electron volt protons are going to collide. And then you look for new particles, Higgs boson or something like that, which is the only thing they have not seen yet, probably. Maybe they'll see other things. And as some of you know, this is a tunnel 100 meters under the ground, 26 kilometer circumference tunnel. 1/3 under Switzerland, 2/3 under France. So the joke there is you need visa from 2 countries to do experiments there, because the particle is going under 2 countries. And that's a $2.5 billion project, and we are supplying 1% of that in kind. And much of it is going from Madhya Pradesh, by the way, Center for Advanced Technology, giving them 1,000 sextupole superconducting magnets, decapole magnets, some high technology software, control software and all that. And the deal is 1% evaluated at European costs. Half of this $25 million, maybe a little more now, will be treated as our contribution to the Large Hadron Collider. The other half will go into an India fund, which will fund our scientists when they go and do experiments. And there are a couple of detectors, the ALICE and the compact muon solenoid, in which we are involved. So that cost will be covered by that India fund, which is operated by Sun. And then of course we have the Rice Genome Project. Miss Professor Kush, who was in Philippines, International Rice Research Institute, is of course one of the world's best rice breeder. He has helped DBT to organize this in Delhi, Indian Agricultural Research Institute, in the south campus of the Delhi University, where they have delineated one of the 12 chromosomes of the rice, which is a big contribution. They have done a little more than what was expected of them. See, today more than at any time in history, technology is power. And this is a paraphrase of Alvin Toffler. Alvin Toffler said many years back that there was a time when violence was power. Today wealth is power, and tomorrow knowledge will be power. That's the statement of probably the greatest modern futurologist, Alvin Toffler. But I paraphrase it. Why was violence power? The guy who had the best technology for creating violence was the most powerful. Why was wealth power? The guy who had the best technology for creating wealth was powerful. Japan, who had the best technology for optics and electronics and shipbuilding at one time. Maybe not anymore, but at one time. Knowledge will be power is IT and BT and all which is already beginning to come to pass, in which Indians seem to have a special talent. What is the common thread in all this technology? That's why I say, instead of putting 3 statements of Alvin Toffler, I give one: technology is power. And if technology is power, the name of the game is technology domination, both by countries and by companies, whether it is strategic weapon systems or there is human genomics. And it is done by 2 methods. intellectual property rights, technology control regimes. And India cannot say, I want to play cricket, but I will follow the rules of Gilli Danda. No, it's not possible. We have to play the game according to rules which have been created. And today we can do that. There's nothing in technology, in principle, which is beyond us. And we had one of the management gurus, C.K. Prahalad, and he was saying there is no problem for India to grow at 10-12% growth rate. PM wants 8% GDP growth rate. Today's India, according to Prahalad, even a higher growth rate is in principle. See, we need synergy. If you look at it, whether it is any technology, critical technology, including rural development, which I talked about, for India to develop, to become a developed country, it requires a large number of efforts. Choice of critical technologies. I'm not talking of basic research. Basic research I have defined as something a civilized country like India needs. But I'm talking of applied research, technology development, choice of critical technologies, prioritization of R&D in applied areas, human resource development, academia-industry interaction, being proactive in choosing the areas for S&T cooperation. And in the Pravasi Divas, I was telling the role of scientists and technologies of Indian origin in collaborating with us, the initiatives of the government, the fiscal incentives you go to give to industry and so on, can put a whole list of items which have to be attended to for India to develop. Each one of them requires synergy individually. Suppose I talk of academia-industry interaction, it requires synergy between academia and industry. If I talk about human resource development, it requires synergy between the national lab system and the university system and so on. Suppose you say fiscal, the incentives, whatever the government, which Prime Minister is willing to do, only he wants to tell him what is it we want in order to improve the S&T environment in the country. That will require interaction between the S&T system and the government and so on. So each one of these efforts requires synergy among the concerned parties. But there has to be coherence among all these efforts. All of them, like if you have, of course, synergy has local coherence. I'm talking about global coherence. Each effort gives you a momentum to India. But all the vectors must add and point in the same direction. That's coherence. I've coined a new phrase, which I did in internet search. I found nobody has used it, at least in this context. What I call the need for coherent synergy. That is, every effort, synergy. Collectively, coherence. So I've coined this new phrase, coherent synergy, which has happened in a manner of speaking in the nuclear area. And we must do that in all other areas of technology development, including rural development. I'll close with this, and I thank you for your attention.
You are listening to an audio lecture on nuclear energy to rural development. Lecture was given by eminent nuclear scientist of India, Dr. R. Chidambaram. Announcer was Dr. Harkirat Bains. This program was recorded, edited and directed by Amar Bahadur Yadav. This audio program was produced and presented by Electronic Media Production and Research Center of Madhya Pradesh, Bhoj Open University.